Okay, good evening. Welcome to Math for Kids number
61.
61. Tonight we're only going to do one problem. The problems today are from Olympiad 26, problem number 2 and problem number 3, but when you see Olympiad 26, problem number 2, you'll see why we're just skipping it. It's counting some stuff, and I think
That should be easy.
well, it's not that it's easy, it's that you can figure it out on your own. Okay, you ready?
Yep.
Alright, the product of three positive integers is 40. How many different sets of three integers have this property if the order of the numbers doesn't matter? So 1, 5, and 8, which multiplies to be 40. 1 times 5 is 5, 5 times 8 is 40.
Yeah.
Is the same as 5, 1, 8. Okay? So this is an interesting thing that we haven't really talked about before. About how do you count?
I have an idea.
Okay, what would you like to do?
You could factor 40 into primes.
Okay, that's actually not a bad start. So what does 40 equal when you factor it into primes?
Well, it's 2 cubed times 8 times 5.
2 cubed times 5, that's right. 2 cubed times 5. Okay? And we need to find three numbers that multiply together to equal 40. So we know we're only going to be using some 2's and a 5, and then of course what number can we also throw in there in the multiplications?
1.
We can throw in a 1. Okay? Now here's the tricky thing when you're counting. We got to make sure that we don't count this like 158 and 518 as being different. Okay? So what we're gonna do, the trick I want to show you to make sure you count them right, is we're going to try to arrange all of them in increasing order, or at least not decreasing. So the first thing we'll write down is we'll look at all the groups of 3 that begin with 1. Okay? So if we have 1 as the first number, now we have to have two products, two numbers that multiply to be 40.
Oh, 1 times it has to be.
Is that what you said? 1 and 40? Okay. So does that multiply to be 40?
Yeah.
Okay, so this is the smallest. Maybe I jumped the gun on that, but 1 times 1 times 40 is a good starting one. That's 3 positive integers. It doesn't say they have to be different, right?
Yeah.
That's 3 positive integers, and the sum and the product is 40. What's the next one if we use the next smallest number here?
220.
1, 2, 20. Very good. Okay. Can you stand over by the board just a little bit for me?
1.
What would be the next smallest one? Could we use a 3?
No.
4. 4, okay.
4.
1, 4, and 10. Okay, awesome. Okay.
1.
1, what would be the next number we could use?
5, 8.
1, 5, and 8. Awesome. Great job. 1, 5, and 8. Now what would be next? Could we use a 6?
No, 6 times. Oh, 6 times something is 42, so it doesn't work.
6 times.
7
Okay.
is 42.
Okay. What about a 7? Could we use a 7?
No, because 7 times 6 is 42.
Right, because 7 doesn't go into 40. What about 1, 8, and 5? Does that work?
No. That equals.
Right, we already counted that one. Good job. Where did I put that eraser?
There's some stacked up
Actually,
over
just
there.
grabbing that one? That's right there, thanks. Okay, so we already counted 1, 8, and 5. Okay, so good. So now we've reached the end of all the ones that start with 1. Now we just have to be careful, and if we're going to start with 2, we can't use 1 anymore. Because if we did, for example,
1, 2, 2.
actually, you know what? I'll let you keep standing where you're standing, and I'll make my 2's go over here. Ugh, I have a hard time erasing. If I did 2, 1, 20, well, we've already counted that one. That's why we're saying they're either increasing or at least not decreasing. Like 1, 1, 40 is not decreasing. Okay? So if we're going to start with a 2, what's the next number we can consider? Can we do 2, 1 something?
No.
No? Okay. What can we consider it though?
2 times something times something.
Right, 2 times something is 40.
2 times 10 times 2. 2 times 2 times 10.
Okay, right. So we can't have a 1 here, but we certainly can have a 2. 2 times 2 times 10. Okay? That's nice.
Any more 2's?
Any more 2's? Well, you want to check until we get the flip down here. Remember how we got that flip with the 8 and 5 and they were the same? So 2 times, can we use a 3?
No.
What do our last two numbers have to multiply to be?
To be a 20.
20, okay, so we can't
So
use a 3.
5 and 4.
Okay, so what should we check next?
2, 5, 2, 5. You can do 2, 5, 4.
Right, but how would I write that?
2, 4, 5.
Right, so the next number I would check would be 4 and then 5. Okay? Then I would get 2, 5, 4, but we already counted 2, 5, 4, right?
And so far we have 6.
Okay, so far we have 6. Now, what's the next number I can start with?
4.
4, okay?
4, 5.
And what do my numbers have to be? What do these last two numbers have to multiply to be now?
To be 10.
Okay.
You can't
Can I
use
use a
4,
1?
5. No, you
Can I
can't
use
use
a
5 too.
Can't use a 1 and I can't use a 2. Can I use a 3?
No.
No, because it doesn't go into 10. 4 doesn't go
No.
into 10. 5.
No.
So 5 is the first one I can use.
But you.
So 4, 5, 2.
But you know.
We already counted that
Yeah.
one. Okay. So now we're already repeating. So that means we're done.
There's 6.
Okay. So there's 6. Okay. So this is probably going to be a little tricky. And by the way, there's lots of other ways we could have done this, but I wanted to show you kind of this neat way of arranging them in the right order. Okay? Does that make sense?
Yep.
So there's 6 pairs of numbers, of triples of numbers that multiply to be 40.
Yep.
Okay, good job tonight, sweetie. Good job.